Okay, today I will discuss the most important portion of the 11th board oriented IITG NEET. Both will be included from my lecture. Projectile motion. And there are two parts of projectile motion when your body is projected from the initial velocity from one position to another, initial velocity to horizontal position, final velocity. And next one, when a body is projected from height. So there is so many example of projectile motion, just like fountain and just like we are playing volleyball, and just like an example, just you can see here like that. This is the projectile motion. So during this projectile motion, we are seeing this is the projectile motion. So in this direction, the curve path or projectile, this is called trajectory path or curve path. So now, what is the construction of projectile motion? So this is two-dimensional, that is the y plane and x plane. And in the vector quantity, we know that the two component, that x component and y component, is a two-dimensional motion. So there is a trajectory path with the velocity. So this is a parabolic path. Okay. This is the parabolic path or project curve path on the uh, Earth surface. So in this Earth surface, this curve path or parabolic path, the air resistance will be negligible. Air resistance normally negligible, and this is the initial velocity from here. So we can see like that. This is v, and this is the maximum height where this is maximum height where Vy velocity will be 0, and this is the horizontal range. And in this direction we see there are the three component like that, and there is the minus g will be act. Okay, so this type of component will be breakdown, and acceleration due to gravity is normal in minus g act. So this is horizontal range, and this is the maximum height, and from the time of ascent, and this is the time of descent. So in this horizontal motion, the component will be u cos theta. Okay, and the horizontal motion, vertical motion, u sin theta component. Break up. Okay, this is the basic diagram of the projectile motion when a body is projected from the initial velocity. This is the final velocity, and just like an example like that, this is the curve path. So this is the geometrical structure of the projectile motion in the two plane u cos theta, u sin theta. This is minus g is acceleration due to gravity from the downward act, and this when the velocity will be 0 at any position where the maximum height will be found out. This is the theta. So this theta, when the 45-degree angle, when any body will be projected from the angle of 45 degree, then this is the maximum. So in this projectile motion, usually we can find out the maximum height, horizontal range, and time of flight. Okay, so first of all we can discuss the horizontal motion. So in the horizontal motion, the acceleration, that is ax is equal to 0, and the acceleration due to the x component will be constant and 0, and the ay is equal to act as ay is equal to minus g. So acceleration due to this time. So in the horizontal motion we can say h is equal to horizontal motion What is the horizontal motion? Which type of it? The horizontal range, and this is the so you know that v is equal to u plus at. So that is Vx is equal to ux plus ax into t. So we know the association due to gravity in the horizontal motion, that is ax is equal to 0. So Vx is equal to ux, that is this term will be 0. So Vx is equal to ux. Okay. So means final velocity, this is ux. And this is ux means u cos theta. So u s is equal to ut plus half at square. So displacement of the horizontal motion we can find out from this formula, s is equal to ut plus half at square. So in this direction, that is displacement from the horizontal motion, that is r or x. So this is x is equal to ux t plus half ax into t the whole square. So this is x is equal to u cos theta into t plus 0. So x is equal to, find out easily, we can find out this, x is equal to u cos theta into t, or t is equal to x upon u cos theta. This is the displacement. And the equation, when the body is projected, that is called trajectory path. So from the trajectory path we can find the most important relation. And you can see from this diagram, this is the horizontal range in the horizontal position, and this is vertical motion or vertical position or vertical motion. So in the vertical position we can find out the time of flight, because this is acting on the vertical position, and horizontal range can be found out from the horizontal position. So when we find out the horizontal range, we have to cover the horizontal position or x plane, and when we will find out the time of flight or the maximum height, then we have to cover the vertical position or y plane. So time of flight, this is called from this position to this position, this is kinetic energy, from this position to here, and from this is the, when the potential velocity will be 0, then this is acting the potential energy. And this is time of ascent, this is time of descent, the complete, that is time of flight. So in the projectile motion there are three things is the most important. First one, the horizontal range, time of flight, and the vertical. So we can find out this here. And we know the trajectory of this is the trajectory for a parabolic path of parabolic nature. The best example, just like emoji. This is emoji smiling inside. So when we are the positively, we have positive feeling, so we are smiling. So this is the positive direction, and when we are feeling sad, the negative. Two types of parabolic equation or find out. Okay, next one, u cos theta. So we know the equation of displacement as is equal to ut plus half at square. In the vertical position, vertical motion, s is equal to ut plus half at square. So s is equal to, that is y is equal to ut, that is uy into t plus half at square, means a y into t ka whole square. So we can say that y is equal to, that is y distance, we can find out uy, that is u sine theta into t plus half into ay is equal to minus g into t whole square. So y is equal to u sine theta into t plus half minus plus minus minus half gt ka whole square. So easily we can find out half gt square. So y is equal to u sine theta into t minus half gt square. Easily we can derive this value will be found when y is equal to 0 and in vertical position. So we can derive the next equation, that is y is equal to u sine theta, that is y is equal to 0 u sine theta into t minus half gt ka whole square. So from the simplifying this equation, we can easily find out here, that is u sine theta into t is equal to half gt ka whole square. So this t will be cancelled out from this t, and this is the time 2u sin theta upon gt. Okay, so t is equal to 2u sin theta upon g. So this is the time of ascent and time of flight. We can easily find the vertical position. Okay, so how we can find this is the time of flight, we can easily find out, and easily we can find out the displacement or the horizontal range. So we know that the velocity is equal to velocity, that is v is equal to displacement upon time, and s is equal to v into t. So by using this formula, we can easily find out the horizontal position or horizontal range. So r is equal to vx into t. So here this is the r is equal to vx, means horizontal position, and that is u cos theta into t, and finally horizontal range will be u cos theta into time of flight, that is time means time of flight, 2u sin theta upon g. So finally horizontal range will be u square 2 sin theta into cos theta upon g. Okay, so we know a very important portion, that is 2 sin theta 2 sin theta into cos theta is equal to sin 2 theta. This is the trigonometric formula. So we can put here r is equal to u square sin 2 theta by g. Okay, so this is the horizontal range. How we can find out the horizontal range? And second one is the most important part, the horizontal maximum height. So we know that v square is equal to u square plus 2as. So this is the v square, that is vy is equal to uy square plus 2ay into h. So we can find out the v square y means velocity on vertical position, and u square, that is u sin theta whole square minus 2gh. Okay, so when at any condition, when the vertical, this is the vy is equal to 0, that is the maximum height, those position will be found out where the velocity will be 0. So this is 0, and u square sin square theta minus 2gh. So h is equal to u square sin square theta by 2g. So finally this is the maximum height. Easily we can derive the three most important equation. So we are in this diagram, we can see the three planes, that is x plane and y plane. So we can see as a chart of like that. This is the chart of x and y plane. So we can find out the x plane, and this is y plane. X plane, that is for horizontal motion and vertical position. In this direction, ax is equal to 0, ay is equal to minus g, and second one is x professor u cos theta and u sin theta. Okay, so this is the basic equation we can derive the projectile motion. So this is the basic definition of the projectile motion. We can easily derive the most important part of the projectile motion. Each point there is a slope will be derived from normal direction, and this is a horizontal range for x plane and vertical position. But important, it is to be noted that in the vertical position or vertical motion and the y plane, we can find out the time of flight and maximum height. And horizontal will be for the horizontal position, that is x plane. So when we are using the vertical position, so component will be taken as y coordinate, and when we will find out the horizontal range, So the component will be found out with x component. So you don't know, we hesitate why u plus at can be x, because this is a horizontal motion and x component. Okay. So this is the basic diagram. You can take a screenshot